Right. So this is a webinar about DeviceCode. It's the last webinar of the OpenChain year. We've done quite a few this year. I believe this is the 14th webinar, and it brings our total in terms of webinar productions to well over 90 in the last 4 years, a considerable number. Before we get started, as usual, I'll show the antitrust policy notice. The full antitrust policy can be found on the Linux Foundation website. And if you're from a member company, you can ask any questions of our counsel, Andy Updegrove. So, jumping into the main part of the webinar, our speaker today is Armijn Hamel, who has been involved in open source license compliance for a great many years, and will be well known to some people from his time in, for instance, the GPLviolations.org project and his work around binary analysis with binary analysis tool and binary analysis next generation tool, both open source projects that have assisted people in our space of license compliance over the years. Now, today, well, the discussion is going to be quite big, I think, and about device code. So, before we get started on this in detail, I guess we should say that this webinar is going to be pretty informal and a bit of a conversation. So what I wanted to do to kick off was to ask you, Armand, what is this in terms of a project for you? So, this is about data, it seems, and
That's correct.
integrating data into other places. That's quite different from the binary analysis that you've done in the past. What took you here to this topic?
Well, so one of the reasons that I started this is that for quite a few number of years, almost 20 years already, I've seen that a lot of people are talking about devices as if they are uh, built in isolation and not in a certain ecosystem or maybe even a market. So when I was still a student, I did some research into UPnP security and or insecurity rather, because it's not probably not a very good protocol. There were quite a few implementation errors, and I did some research. I presented it at a security conference, and it got picked up by some security companies who then filed CVEs, of course, without mentioning my name. So that's not very nice. But they filed separate CVEs for each of the devices that I mentioned, even though I knew, like, wait a minute, this is all the same bug because it's in the same software. And a lot of the people out there think that when you buy a device in a shop and you buy it from a certain brand, it's coming from the factory of that brand. And we know that that is not true because the industry, what they do is that there are ODMs, so original design manufacturers, who get their basically their board and or at least the chip plus the software from a chipset manufacturer that then sources it from open source projects. I mean, that's how the industry works. So there are these people who think if I buy from a brand A, it will be a reputable brand. It will be better than brand B, even though they might be coming from the exact same factory with the exact same software on it. It's like, wait a minute. So I wanted to be able to look at to actually find out if I have a device, how close is it or how similar is it to other devices? And manufacturers, they are kind of secretive about what's actually inside and where they get their stuff from. Because obviously, if you know where the stuff is coming from, you could buy it from a cheaper competitor and still have the same device, or flash it with a different software and then just have a cheaper device. And this market is, especially consumer electronics, margins are thin. So So being the first to market and being the having the highest margin is actually imperative because it would be uh, the difference between a profit or a loss. So that's why companies tend to not really disclose where they're getting their stuff from.
This reminds me of two things. One, back around 2006 or 2007, someone wrote a driver for a webcam for Linux. And then it turned out that fundamental chipset was used in virtually all webcams available at the time. And this person's project grew to support dozens or more of the webcams on the market, this incredible list of webcams, simply because the guts were the same. They were from the same factory or original device manufacturer, I suppose. And another interesting tale out of technology, different field. A friend of mine used to work in the oil industry and pointed out that some people are quite obsessive about which gas station they go to. They're like, oh, I want to use Texaco or BP because that's good. And my friend pointed out he was working in oil tankers, and he pointed out that yes, indeed, BP charters an oil tanker which goes to a refinery, and then BP has garages, but the fuel from the oil tankers is pooled, refined, and then sent out. It's all the same gasoline, whether you're going to Texaco or BP or whatever. The companies are transporters and deliverers, and ultimately, the gasoline is a pooled resource via the choke point of refineries. So anyway, same deal. You know, if you buy your gasoline, it's from who knows who and where, and it doesn't matter. And if you buy many consumer electronic devices, maybe it's the same guts, despite the brand name. Now, I
Well, the,
understand. Sorry?
there are a few changes every now and then, depends on the brand. But yeah, usually it's, I mean, 90% open source of well-known components.
Yeah, and that makes sense. I mean, let's just say hypothetically, keeping with the webcam thing, if you're going to do a 180p full HD image, you need a sensor, obviously, and you're going to source that sensor from a company, whether it's Sony or someone else. But to take the data from the sensor and to process it and to deliver that data, that code isn't going to be so unique. It's not like we're dealing with quantum physics here. It's taking raw image data and putting it into a format that can be sent to the computer. So you can see that open source is a perfect fit. You can equally see that apart from the specific of talking to this sensor's raw data, everything else is probably the same in terms of what you need to do. It's an
Yeah,
interesting field. And I understand that this device code project, it's unlocking this data by having resources on the net. And you know, on the overview of this talk, you talked about data from various wikis,
yeah. So
integration.
there are some people who are obsessed about documenting what's inside devices, and they're publishing this on various wikis. So there is Tech Info Depot, which is a fork of uh, Devi Wiki or Wiki Devi, I think, which is some Russian site. But they at one point they forked and then they diverged. Uh, and then there's also the OpenWRT table of hardware, where there's also quite a bit of stuff documented, but mostly for devices that are supported by OpenWRT. And these wikis, at least the one that I use the most as Tech Info Depot, it is suffering from it's sometimes it just doesn't respond. Website's basically down, or it's just super slow, or it gives errors. And if you're using the mobile version, it's showing all these ads, and I just don't want ads. So what I've done is I've written some parsers for dump files, because these are mostly what are it again? MediaWiki, and OpenWRT publishes a CSV dump. So I've basically um, downloaded those, then processing them and putting them into a separate format that I can then reuse. So basically, I'm parsing the files, outputting some JSON per device, and then making that available for further processing. And also doing a lot of cleanup because um, there are people are well, basically people are people, and they are just trying to shoehorn data in places where it shouldn't be. There is a famous Simpsons episode where Homer Simpson has to fill in all kinds of forms, and then he's just there. Then there is this line that says, "Do not write below this line," and he writes down, "Okay." That's basically what people do in wikis as well. They try to put data in all kinds of places. Unless you really guide them, they will just put anything anywhere, and then just trying to parse that and work around it, and trying to extract the useful bits from that basically random stuff, just trying to get the signal from the noise. That's a challenge because people are
Well,
just doing something.
that was actually my next question, which was, unlocking data, finding the data from online resources. Okay, fundamentally, that's a solvable problem. And the idea that people are obsessively documenting the details of which ODM made a chipset that's included in these end devices from OEMs and, the endpoint companies, that makes sense. But the fact that this stuff is just spread across the web in different formats sounds like quite the data processing challenge. How did you address that to try and make sure you had fidelity as opposed to a train wreck?
Well, took many hours just basically going through things by hand, and then just basically by I've got this Python script with many exceptions. Like, oh, if you encounter this, then it should actually read that. So it's a lot of manual work. But also sometimes I just basically say, well, screw it, I give up. So I just don't include it. It's like, okay, well, if I do not know for certain that it is this kind of data, then I just don't include it.
Now, this approach of trying to find the commonalities between devices, which can allow us to look at entire classes as opposed to individual products, sounds like it might fit into a useful bucket for something like the CRA, where,
Yes.
companies are liable. And this could mean that a company, in theory, could notice that coming through the supply chain, we now know there's a problem with this device. We're beginning to see commonalities. We know that this ODM board is a problem. Are we using it? Which is an interesting route to potential CRA. I wouldn't use the word compliance, but CRA readiness. Is this something you've talked with people about? Is this something that's in discussion with other people or companies in Europe?
Well, it's definitely on my mind. So CRA was one of the things that I've been that I wanted to address, or at least just it's been my long-term goal to basically find out, like, if I have this device, how close is it to another device that I already know is vulnerable. That's
Right.
my ultimate goal, and of course that's a perfect match with CRA. So I've been
That
discussing it with, for example, NLNet Foundation, who is actually funding the creation of DeviceCode. So I've been discussing it with them, but I feel that maybe this is an approach that people are not expecting yet. So
right.
they're still very much focused on source code and maybe a little bit of binary code, and not like, hey, let's look at what's actually inside in the hardware to find out if it's the same stuff as we already know.
Which, when you think about it, is quite an interesting thing. If there are shared components, there's a shared uh, surface of vulnerability. It's quite amazing that this is a space that seems relatively unexplored. Now, I understand the point you made earlier. Companies might be coming to market with a product and have a very competitive market space. They don't want to advertise that they're using chipset from ODM-A, and that's the same as their competitor who's also using the same chipset. Um, I get their commercial imperative to hesitate on making this picture, but it seems that for purchasers, especially governments, having this type of information not only is useful now for something like the CRA, it could have been very useful in the past. Why do you think it doesn't exist? Beyond the simple commercial imperative that company A doesn't want to say they're using generic device from ODM-B.
I think it has never been on people's radar because they are seeing it as how should I say this? I've had discussions with people in the past who think that when you buy a device such as an IP camera, they're not seeing it as a computer, even though it is. They're seeing it as a camera. So
Right.
a lot of people actually are they think they are different things, but they're
Yeah.
not. They're not. They're also not seeing a car as a iPhone on wheels, basically, which is increasingly the case. They have a different mental model of devices and what they are. That could be a reason.
Yeah, that could indeed be a solid reason. Now, Yari pointed out that the EU's product liability directive probably has implications in this area as well, not just the CRA. And of course, Yari, you're right. The product liability directive for the viewers, it essentially is telling people to be aware that if they're bringing products to market, that they're liable for those products in certain areas like safety. And safety goes beyond, let's say, a medical instrument that is malfunctioning. Safety is a pretty big topic. Now, when it comes to the device question, people thinking that they're buying an object that is defined as opposed to a computer, which is programmable, it does seem to be fairly prevalent, actually. And I remember around the first time, this is probably about 15 years ago, when people became more aware in the technical field of stuff like microcode updates, where actual CPUs would be reprogrammed with essentially a firmware update to the CPU, including to work around damaged silicon. If I recall correctly, either Intel or AMD had to do that way back when. It began to become evident that virtually anything of complexity was pretty much software defined. And you could do workarounds, but you could also have flaws integrated in software bugs. And that means you could fix them or choose not to, which is increasingly with stuff like the product liability directive, not a choice that's available.
Yeah, but
So
just sending updates is actually quite old. I mean, the Voyager, they're sending software updates to work around broken hardware.
yeah, which has been very impressive. They brought it back several times in the last few
Oh
years.
yeah,
And I suppose this does raise a question. I mean, one area that comes to mind is automotive. And this is leaving the track of, let's say, the scraping the data from wikis on consumer electronics. But automotive has serious challenges in addressing something like over-the-air updates because of the security needed to make sure that the over-the-air update, A, is from the right organization, and B, will be successful and not brick the car. So it's a big challenge. Now it's probably less of a challenge to update the driver on a webcam or similar, which would seem to indicate perhaps that the research you're doing is most immediately useful in the sphere of consumer electronics.
that's correct.
Yeah. Do you think that this is device code is something that could end up being integrated with SCA tool providers, organizations like Nextbee with scan code or FOSS ID with their solutions. is this something that they could include in their product portfolios for automation?
So the goal is definitely to integrate it with the About Code suite of tools. So NextP actually they moved all of their tools into a nonprofit called About Code. So I'm working with them. I'm working with Philippe on several things. There's a reason I call it DeviceCode because it follows the same naming convention as the other About Code tools. So yeah, it's I am planning on integrating this and basically at some point when I see like, hey, a certain device is very close to another device that I then can query vulnerable code and then say like, hey, do you have a CVE for this particular device? So that's the ultimate goal.
Let's dig into that a bit. So about code then covers solutions like scan code. What else does it cover? So we're talking about a nonprofit maintaining open source automation tools and presumably data tools as well.
Yeah, currently in About Code, there's vulnerable code, scan code, what else? Scan code IO. There are a few at match code, and there are a few other ones that they've put into that project.
It's an interesting move. Now, I actually talked with Philippe a while back from Nextbee when he was telling me that they're planning to do this. So it's interesting to hear that they are doing it. And this activity of yours, device code is or will be part of that suite of options for compliance and security automation and analysis.
Will be because he first has to unlock a little bit more data so that I can reuse it.
Okay, so that they're also unlocking the data to allow people to use the tools in-house or something quite easily.
Well, vulnerable code still needs to be able to unlock, make it easier for me to query for a certain device. Say like, hey, do you have security data for device XYZ? And that's currently still missing.
Now, going down this route of, having a nonprofit with a collection of solutions for compliance and vulnerability analysis, obviously is quite useful. Um, it's not the only thing in town. For instance, there's a much older project, Fossology, that has been used for license compliance matters. And there's another software suite called ORT, the Open Source Review Toolkit. Uh, how do these things differ? How does the About Code collection of solutions differ from ORT, or are they simply compatible, similar options?
Well, you will have to talk to Philippe about that because I actually don't know. So I've used both tools, but that's about as much involvement as I have there.
Well, that makes sense. I mean, I suppose the follow-up question then is if you've used both tools, what made you choose About Code as the home for your device code project?
I'm not sure I want that to be recorded.
Okay. Ooh,
I'm just feeling a little bit more comfortable with the scan code and the vulnerable code things.
now, if I recall correctly, scan code, which is the license scanning software, maybe it's expanded since then, has been around for quite a while and has been quite extensively used. And it's also plugged into various things, like over in Korea, Foslight, which originated from LG Electronics and is now a multi-stakeholder open source SCA solution. If I recall correctly, that uses scan code as one of its scanner options. So scan
Oh
code
yeah,
there a long time. Uh,
yes, Scan OSS is using it as well. Other commercial companies are using it, at least internally, to verify results. So yeah.
Now this device code project specifically, what you're working on with the data about, what commonality do we have here? What ODM stuff? might affect a category or class of devices. Is device code purely a database of data? Is it tooling? What form does this take in implementation?
So there are a few Python scripts that process various sorts of data. So there is the wiki dumps, but also PDFs that I download from the FCC. So quite a few devices have an FCC associated with it. At least the devices that are uh, coming onto the US market, they have to have an FCC ID because otherwise they're not allowed on the market. I think that the EU doesn't have something like that, unfortunately. But the FCC then also just forces the companies to send them documents and to republish them.
Right.
So if you go to the FCC website, which is horribly slow, I think they're still using something based on Solaris, like iPlanet web server based on Solaris on a on a very old Sun machine. It's so slow. It's so slow. So there are quite a few projects that have downloaded all of the FCC stuff and are republishing it. So I'm downloading from those websites. Uh, but there you have all kinds of documents, including user manuals from the devices themselves. So that's quite useful because then I can process those PDF files and then look through the user manuals and then search for all kinds of keywords. It's
Hmm.
like, hey, maybe there's a GPL license offer. Interesting. So that's something that I also do. So basically, the wiki data and then the PDFs from the FCC, if available. That's the
Right.
data that I process, and then I try to merge that one into one data file. What I also try to do is when I have the same device in the various wikis, I try to consolidate that information to actually make it more complete. Because one wiki might have one piece of information, the other might have another piece of information. Sometimes conflicting as well, which is interesting. Like, which one should I choose? And I try to consolidate that and then put it into a single output file.
And this then is a database, not a tool itself.
So now what you get is a collection of JSON files.
JSON file. So you'll have to process them with another tool.
Correct. Yes.
And is this something that's likely to be supported by the About Code suite itself, or will people need to build custom tooling?
So what I'm trying to push Philippe to include it, but he already has quite a few other projects on his plate. So what I'm doing is I'm allowing people to process the data themselves if they want to. So there's maximum flexibility. And what I also have, I have a little bit of a text UI browser for the data. I could show it to you if you want to.
Sure, why not? And I
But I would
noticed
have to.
Yari was just pointing out that ORT has scan code as one scanner option. ORT works with FOSS-ID or scan code, and it has reference implementations with Ascalono, LC, Licensee, and ScanOSS. Just a side note from Yari there about the open source review toolkit, utilizing components from the About Code project as well. The reason I asked about tooling, and it's interesting you say it comes in JSON format, is that having data itself requires a way to query it. So it sounds like there's an additional step for people to implement this solution. And maybe that's something that About Code will address. Maybe it's something that ORT or FOSS-Lite could also address. Do you intend to talk with these other projects in the new year, for example?
Well, if they're interested, then of course there will be a tooling workshop just the day before FOSDEM in Brussels. So it's I will be there. So if people want to discuss it, then I'm open for discussion. But if I want to show you, then I will have to be able to share.
All right, you should be able to share the screen now. I've turned off mine.
So can you see that?
Yep.
Does it need to be bigger?
No,
So
no.
basically, it's just some Python stuff. I've got this repository with all kinds of data. Just to give you an example, let's go for the first one. So basically, there is what I've done. I've processed stuff, and then there's this thing with JSON that's output, and that people can then process. And then I've got this little browser, which yes, it is text-based. Because it's a lot of data, it takes a bit of time. You should probably buy a new device. So, what do you want to see? Which brand?
Okay, let's pick up something from Acer out of curiosity.
Yeah, just quickly, I've got various views where I have a brand view, an ODM view, so I know which ODMs have made stuff, the year, which brand. So it seems that most of the things that are in the wikis are from D-Link and then TP-Link. And it's quite fun to actually see this change throughout the years. So that you can see that in earlier years it was very popular that certain brands were used, and now it's different brands. So you can also spot trends. Which brand uses which CPU? So you can here see like it appears that Netgear is mostly a Broadcom user. TP-Link likes Qualcomm Atheros, which ODMs are using which chipset. Maybe I should uh, decrease the size a little bit, it makes it easier. And there are a few other things, but you wanted to have Acer. So, okay, whoops. There we go. Oh, there are only 4 Acer things. Maybe there's something wrong with the processing. Let's go for a different one. So here, ASUS, they've got a lot more, and it's almost like it also starts with an A. So you can click around a little bit. Here is a little penguin that says like, "Hey, I've confirmed that that this is running Linux." Here, things with the phone, because then there's some phone functionality. F here means there's some FCC data. So it appears that most of the ODMs that are being used is unknown.
This is
But there
actually
are also
quite a usable interface already. So it's not just pure JSON you're providing. This interface is perfectly usable for people to get started.
yeah, but it's still it's text based, it's terminal based, and some people don't like that. So quite most of them that are at least in the wikis are from a fairly recent date, which surprised me because Asus is at least was one of the more popular ones, I think, a little bit over a decade ago. And they're mostly using quite often Arcadian.
When it comes to the ODM unknown, and it's a lot,
Yeah,
what's going on there?
it's basically people didn't fill in the data in the wiki.
And when you're faced
So
with that, let's just say you've got an unknown, and maybe you find a vulnerability. What might be your next step to try to work out if you have exposure in your portfolio, or if you know
well,
you've got exposure,
the
how to
best
find
the
out?
best way would of course to be to analyze the binary and then just work from there. But that's a different view on the device.
Right. So once we have something like this device we're looking at here, the GTAC 2900 gaming router, we have certain information about it. Can we have a look at the model and ODM on that?
Sure.
Which, you know,
Here it
so
actually says certain parts
this is Arcadian.
comes from Arcadian, the country in China. Well, I know that Arcadian is based in Taiwan, but let's not go there. So there's Uh, when it comes to the country, then people are also putting in some different information for the same company.
And
Interestingly, what I'm seeing more and more is that there are more devices coming from Vietnam. It seems like the market is shifting.
yeah, I've noticed in Japan, more manufacturing is Vietnam and Cambodia, purposefully so, to distribute the manufacturing supply pipeline. In this case, let's say hypothetically, this router was found to have a challenge, and it's identified as having an ODM being Arcadian. Is this something where one of the sensible steps there for a company might be, are we using any router technology from Arcadian, and then confirm if we're using the same tag? Is it potentially exposed? Would that be the workflow?
Yep, pretty much.
I suppose the question then that precedes this is, how do we find out? Or do you just watch CVEs and wait for this individual project to come up and then cross-reference through this, for instance, DeviceCode database?
Well, that's that's one way. Of course, you could also go a little bit further and say like, hey, proactively trying to poke into devices. That's another thing you could do because the CV thing is quite reactive. It's not proactive.
Interesting that you came onto this. It does seem like a lot of work. So,
It is.
I mean, what did it actually inspire you? If it wasn't a pure business decision, what took you in here down this rabbit?
Well, this has been on my mind for quite some time. So as I said, back in 2006, I already started uh, noticing this. So it's been on my mind for a long time. So it's not purely a business decision. And I found these wikis, and I thought like, hey, that could be fun to do. So I sent a proposal to NLNet Foundation, just a project proposal, like, hey, would you be willing to funding this? And they said, yeah. So I started working on it.
Oh, okay. Interesting. Now, I noticed we do have two people who've dialed in live, and if anyone wants to ask a question, just jump in at any time. I suppose I do have a question, which, oh, there we go. Yeah, I was just going to ask why you chose the year 2014, and I see you've been messing around exposing a whole lot of brands using Arcadian as an ODM.
Yeah, so if you want to zoom in a little bit more, like, hey, what devices have the year 2014 associated with them and actually have the ODM Arcadian, then you can do that in this interface as well.
How complete is this? I mean, what's your confidence level that this covers all the stuff?
What do you mean by with completeness?
Well,
So of the market, that's by no means complete.
I mean, I guess that's the question. Hypothetically, let's say the BT Home Hub 5B is known to have a vulnerability, and people identify, oh, this is Arcadian. Then the question is, how much is impacted? And I suppose that leads us to the question of how complete is your data? Or let's use kind of a more realistic engineering phrase. How incomplete is your data? What's the scope of the data we have in play here? What are the missing parts, and how can it be improved?
This is garbage in, garbage out. So I'm basically limited to whatever I can find on those wikis. So, for example, right now, what I'm here, so I clicked on the home up thing and moved to the software tab here on the right side. And then you can see that, well, you know what, there's no information about the bootloader. And the only thing that I know is that someone typed in this is running Linux, but I don't know actually what's in there. For some devices, what I do is there are boot logs available on the wiki, so I'm also processing those just to see like, hey, can I find names of software packages, and then I include those as well. But I could, of course, enrich this with analysis that I'm doing with Bang, if I get a firmware update and then hoping that it actually is matching what's on the flash of the device, then I could of course enrich this data more with a analysis of the firmware itself. And then it would be much more complete.
So let's move into the making it more complete side of things. I mean, time takes money, and you're getting some support from NLnet, which is a nonprofit.
Yep.
But for this to like grow in scope and utility will require probably significant investment.
Oh
Do
yeah.
you a plan to arrange that investment? Do you see an avenue towards increased commercialization of this initiative? Or if not commercialization, increased.
Commercialization, I'm not so sure. I'm
Hmm.
not so sure. But funding, I'm definitely talking more with NLnet Foundation, and if I'm also looking for different avenues. But it seems that at least in the next year, the EU wants to focus more on the metaverse. So great timing. You're 5 years late, EU. But yeah, so I don't really think that there is a big commercial value here for tooling. But I think that it could be one of the additional tools in the toolbox that people have.
I noticed Yari's unmuted. Yari, do you have a question?
Kind of question, yes. Like, if going back to the wikis, what's really the motivation of people to, I don't know, to dig into these devices and find out, what are the, I don't know, CPUs in those? And then, we already started the discussion about making the tool more commercial. Do you think that there could be some, I don't know, some companies or I don't know who would it be to actually enhance these wikis one way or the other to be more, have more devices there and versions available for
Hmm.
the database, basically.
You're probably not a collector, are you?
Not really.
So
Some
then
wines.
you no, but apart from wines, but not like stamps or vinyl records or anything, because then you
No.
don't understand. You need to have that mindset. Some people are just obsessed about data. So
Okay.
that is part of the mindset that they would just want to be data completists. It's kind of obsessive. So some people just like doing that. So it's
Yeah.
and I guess that for some of these people they started with I want just to know what's inside my device, and they started from there, or they wanted to have a replacement firmware for devices. I mean, that's how I started in this field as well. I wanted to have a replacement firmware for a device, and that's I guess that then they start digging into it and think like, hey, this is interesting, and they continue from there. So
But
that's
it's
why
purely
people.
hobby project for some folks.
Oh yeah, oh yeah. Well,
Yeah.
there are a few. There is some market for having this information, but it's mostly the people who are doing repairs. But they
Yeah.
mostly focus on the hardware side of things.
Yeah.
So the things like iFixit or other things, or other sites like, hey, you need to have this particular kind of screwdriver or this particular kind of resistor, or that's mostly the level, but almost never focused on software.
I suppose that brings me to the most challenging question, which is, the proof of concept seems good, but if the data is known to be incomplete and the source of data is essentially hobbyists, doesn't that mean that moving from proof of concept to market deployability is a near impossibility? But for people to rely on this, they need to have far more coverage and knowledge that the coverage will be accurate and maintained.
Yeah, that's I guess that's a fair thing to say. It will be a challenge. And how to move beyond that? It's going to be a significant investment. So I'm mostly treating it as extra information and not as the main tool that I would be using, but more like, hey, what do I know about this particular device?
So should we regard this as a proof of concept rather than a solution at this juncture?
Oh, yes, yes, definitely.
And with that in mind, let's say it's a proof of concept. Where does it go next? I mean, if it's going to be an about code, will it be actively soliciting contributions? Are you going to actively reach out to other projects to build on this? What is the next stage now that we've seen some of the potential here?
So the next stage for me is that first I'm going to finish OpenWRT support just to ingest that data. And after that, I haven't really thought about that. It's I think that I might be ahead of the market again, and it's that people are just simply not thinking about this approach yet. So it's so I actually don't know what people want or need. So I haven't given that a lot of thought yet.
That does seem like the most important next question.
Yeah. It's I've been mostly been coding uh, to actually make it work. That I just haven't given it a lot of thought yet.
So then to kind of summarize, we're in a situation where a lot of people use common components from ODMs, and therefore, logically, if an issue is an identified problem with something an ODM is providing, if we identify that ODM and that particular chipset or whatever, we can see what scope of threat we have across the entire class of devices. Like we find out 90% of webcams are using the same ODM board. And if that board has a vulnerability, 90% of these webcams are vulnerable. So that's the theory. And what we're seeing on the screen right now is a proof of concept of how to bring some of this together based on scraping data, largely from enthusiast sources. And the question would be how to move from this into something that could be regarded as comprehensive, that it's covering a lot of the stuff on the market. And I suppose that brings us to something Yari's just raised in the chat. Bill of material data. On the commercial side of things, if OEMs are buying from ODMs, if people are purchasing, they should have data about what they're purchasing. Is it possible that the bill of materials trend could be the thing that would tie together this data, that would allow us to have a large corpus of shared data?
It would definitely help, but good luck. That will require quite a bit of legislation.
Right. Well, I mean, I'm guessing the NTIA minimum requirements is opening the door to asking for bill of materials as a market requirement in the US. And we're certainly beginning with things like the CRA and the Product Liability Directive to see a similar motion in Europe, that certain information disclosures or information maintenance and certain responsibilities will be requirements. And we're seeing murmurings in Japan and China. So as you say, you might be a little ahead of the market, but if there was a requirement to identify your ODM for your device, it might help us pin down entire device category challenges as opposed to individual device vulnerabilities like CVEs. Would that be a correct logical construct?
No, I think that actually the knowing which software is in there is much more valuable than knowing which ODM is used.
So this,
Because because even if you have the so companies use a certain ODM, they get their chips from different SoC vendors from different suppliers, but they all source from the same projects, and that's usually the source of the actual problems, that they're using a old version of a software package. So the ODM data is probably could be useful, but it's not the main thing of information that I'm interested in. I'm interested in which software are you using and which version.
So with this particular solution, you're also able to see that. And on the screen, you're showing, for instance, what's using BusyBox and which
Yeah.
version of it. So in this particular case, you start to be able to check across multiple brands exposure. Is this also from the hobbyist sites? They also list the software?
Some of them actually have boot logs, so from serial port output, and then you can, or something like an output of PS or a file system listing. That's some stuff that I'm processing as well.
Right. Okay. So in this particular case, then, to summarize, because we're nearly out of time, this is about capturing as much data as possible from the devices, which to some extent is provided these days by various distributed wikis, and you found a way to scrape them. And consolidating it into a machine-readable format, in this case JSON. And it seems to provide a relatively searchable approach. So the proof of concept seems clear. Very few things there with IP tables. What's going on?
Well, more of them will use it, but it's just that these are the ones for which I have data available. So yeah, I mean, data availability, that's definitely a challenge.
Yep.
So it's that's a gap, and that's something that would be very useful to have. So I'm trying to fill that gap using analysis of firmware files. Unfortunately, more and more brands are hiding the firmware updates behind either a phone app or some sort of distribution mechanism where you cannot just freely download the firmware. So that's making things a little bit more challenging. So yeah, legislation to actually get all of the data, that would be super useful.
Interesting question there about the data. That seems to be the really big one.
Yep.
Okay. So to wrap up then, one last question. JSON format, data structure. What made you decide on the data structure? Is it documented? Can people easily take it, or do they have to view it and reverse engineer the source code to work out what the JSON format is? So, if someone says, "Oh, I might integrate this approach in my tooling," is it easy to do so?
I think it's easy to do so. Of course, I made my own decisions about to put certain data into certain categories. I've documented quite a bit of it in the GitHub repository for this project. So it's I think it should be quite easy to integrate it.
Yep.
Also, I've made all of it. So I've made this data set available, so you don't have to scrape things yourself, download dump files, but you can basically just check out the data repository and just start playing right away.
Right. And with that, I guess we've reached the end of our scheduled time for the webinar. Well, Armin, thanks very much for showing us this work in progress, and I suppose also giving us a view of where the About Code suite scope can go, much wider than, let's say, just scanning for license compliance. There's other things that can be done, such as this, which seems to suggest we should keep an eye on About Code and response to things like this DeviceCode proof of concept in 2025. With that, thank you very much, and
My
I
pleasure.
hope you give us an update once you have further market reaction.
Yeah, so let's touch base again in maybe a year.
Alrighty, have a beautiful day, and for those of you who dialed in, thank you very much indeed. Take care.
Thank you. Bye bye.
Bye.
Thank you. See you later. Ciao.